Yeah, so after lunch a little bit, and it's October. So I thought it would be appropriate if we would start with some cyber horror tales here, as it's getting dark. I've always learned it's important to start with a question, so I'm thinking, anybody in the audience knows who this is? Sad. You guys are not allowed to answer because you saw this presentation on Sunday. So this gentleman, his name is, right. Or it doesn't. Thank you. His name is Benjo. He started a crypto exchange back in 2017, and it's gone pretty well for them. And you should think about this. If you have a really bad day, or if you do something and you like immediately think, perhaps I shouldn't have done that, right? Then think about this guy. On the 21st of February this year, he was moving Ether, or cryptocurrency, from their back office ledger to the hot wallet that they use for the exchange, and this is a standard operation. They do it like two times a month. And he signed the transaction, as he always does, checking the TLS certificate on the website that gave him the QR code, and everything was fine. And he was like the last of three signers to do it. His colleagues had already checked everything. And yeah, as he pressed OK and sent out the transactions on chain, they sort of pretty quickly after that realized that the destination address wasn't really what they hoped for. Instead of the money going to their on-chain wallet, instead went to the North Korean Lazarus group. Not only did they actually lose the money that was being transferred to the office wallet, but they actually lost control of the entire back office wallet, containing somewhere $1.5 billion in Ether. So yeah, this is the cost of lack security. So this is usually when I come in, once something like this has happened. So this is me, Rene Malmgren. Now, question. Did my scary story scare you guys? Yeah. Well, I have more bad news for you, because from our perspective, this is a mid-range attack. This is how it looks when it's bad. I usually use this as a template for several reasons, but it's pretty vanilla when we are talking about high-end capable actors attacking a target. So this is a pretty famous attack. It's what we call a target access operations attack. So that's the most capable ones you have. That means they really zoomed in on you, and they have spent quite a lot of resources to understand how you operate, to make sure that whatever hits you is going to be like pretty painless, but pretty effective. The guys who are doing this is the British GCHQ. The target is the Belgian telecoms operator, Belgacom's NOC, so that's the Network Operations Center. So what these guys did is, and it's actually pretty similar to the Bybit thing, but it starts with a link to a LinkedIn page. Unfortunately for the operator, once he clicks on the LinkedIn page, instead of going to LinkedIn, he is sent to a GCHQ-run hosting service. And there he's presented with a spoofed TLS certificate, because obviously they have access to those. And then he gets a web page that looks very much like LinkedIn. Unfortunately, it also contains a background script. That background script uses a 0 days, so publicly unknown exploit in the web browser based on the exact model of web browser that he's using. And it starts the process in the background. And now that script is the first stage of a multi-stage rocket, which immediately deploys the second stage, which contains a rootkit. And once the rootkit is in, then of course the attacker has complete control over your laptop. If I compare it to the Bybit thing, it's pretty similar, but instead of using the very fancy tools that the GCHQ have to their disposal, they just basically did a regular phishing attack, asking the lead developer of Safe, a crypto wallet provider for Bybit, to help out with a project. So basically somebody asking for help on the net. And as part of that process, they asked him, could you please, I've written my code, and it's in this Docker container. So could you please help me out? I have some problem with some tables. Mm-hmm. And being a nice guy, he decided to execute that Docker container. Now, I assume a lot of people here know, but you do that as root. And that container contained poison, which gave the North Koreans the ability to hack that particular person's development environment. And then, because they are using a cloud service, they managed to get the access tokens. And the second you have access to the access tokens, then you're basically God on the cloud. In this case, because the target was probably, we believe, the lead developer. And from there, they managed to then do a customized attack on Bybit, which they then uploaded to Safe's servers. And that's how that spoof script got into Bybit's system, and they then blind-signed that transaction, resulting in 1.5 billion now, making Kim a lot happier and, of course, Bybit a lot poorer. So we studied a lot of these challenges. And I should say that I had we had a long contract with a, shall we call it, large Swedish telco operator? Telco vendor provider, I should say. You can probably guess which one. And this was as a result of another incident over at an American company called SolarWinds, which also had one of these, shall we call it, visits from external sources. And then that resulted in a supply chain attack on a lot of companies among, I should say, in the Western world. And as a result of that, we got a lot of helpful tips from the regulators about how we should increase the security of our development environment. So this is the result. Everything you see on the left side of this thing, I mean, I'm not here to tell you how to set up your environments. I just want you to inform you that if you're using anything on the left side here, know that we have seen competent attackers who bypass this as if it was a Japanese paper wall. So if you're relying on it for your business, then you might have a nasty surprise. Everything on the right side are things that we have seen that they have problems with. And for us, this is the important thing. So our goal was to build a, as we call it, a hypersecure defensive development environment based on the things on the right side. So, but let's start with the don'ts. Any form of passwords, full stop, they don't work. If you think that protecting your SSH key, for instance, with a password is going to stop an advanced attacker, then I'm sorry. Any form of administrative level access control on any operating system that's out there. So your Windows admin console, it may be very, very effective when it comes to stopping you from changing your wallpaper, because your companies don't feel that you should be allowed to do that. But when we're talking about an advanced attacker, they have rootkits, components off the shelf, and they deploy them immediately. It's the same thing for the Linux kernel. So I don't recommend you to rely on your security for that. Cloud-based authentication services, they're the latest craze. Don't want to name names here because I'm not here to sort of single out any companies, but let's just say that in the SolarWinds Example, the attacker managed to get what's called the golden access token. That means basically they managed to get the cloud-based authentication provider to sign a, like basically universal key for them, so they could do whatever they liked. And also, these access tokens are saved in user space, which is very easily accessible if you're a victim of the phishing attack. And once the attacker has access to the access token, he's basically you. And there's no way for the system to actually differentiate between you and the holder of said access token. VDIs. Now, I know that this has been some form of cruel punishment for a lot of developers in a lot of large companies, because they somehow believe that if you log in somewhere and the code is kept there, then that's going to keep you safe. Now, in the business, we call this browse up. That means you're accessing a higher security environment from a lower security environment. Everybody who is sort of a researcher, they can tell this is a workless refrigerator or a Pegasus, whatever you want to call it, right? It doesn't exist. You will have the security level of the lower environment in the quote-unquote higher one. Yes, my favorite one, pain. There are some companies, especially in Lutheran countries, who believe that if you just torture your personnel, then you can have better security. For me, it's not a laughing matter, because we actually did pretty extensive research, and we had like two competitors, right? One decided, okay, fine, we're going to absorb the pain and we're going to torture our developers, and the other one said, oh no, we're going to find ways around to talk away out of the regulations. And then we did research on what actually happened inside the organizations, and way and behold, of course, in the second option, they were still developing on laptops, right? But the first one who decided to go with the VDI solution, we found out, to our big surprise, that 65% of the developers were still developing on laptop. Because obviously, as that regulation came down, everybody was like, what the fuck is this? And then they managed to find a zillion types of excuses to actually not implement the regulation, right? So pain, very bad. So let's go over to the right side, what actually works. So hard information segregation, I'll get to what that is. But if you are working with anything that is sort of military grade, you'll find very quickly that they believe in firewalls, they believe in separate cables, and they believe in type 1 hypervisors. So they deploy this en masse. So our assessment is, if they're doing it, so should we. Public blockchains. It's very, 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 very difficult to reverse a entry that has been entered into a public blockchain, especially something like Bitcoin that is so visible. So if you are using public blockchains to tag things like, say, identities or GitHub checks-ins, then you can be fairly confident, even after a deep compromise, that you will be able to restore your integrity. Hierarchical key stores, yeah. This is one of the things we were looking into. Most crypto wallets use them, and there's a lot of money floating around in the digital space today that use this thing to make sure that you actually have order, or at least traceability on a lot of keys. So unlike, say, generating your SSH key for the 55th time in your home directory, you should have a master seed that then generates the keys for you. Type 1 hypervisors, it's a nice requirement that we saw from, and this was like super funny, among the NCSC in the UK. So that's the regulatory body part of the GCHQ. They recommend us to implement type 1 hypervisors on the NOCs. Interesting, given like what I had on the previous slide. Defense in depth. So make sure that you have several layers that the attacker needs to penetrate. So they will have to actually use several 0-day exploits to be able to traverse or to do lateral traverse in your network. Correctly configured 2FAs. That was a bit of a surprise. My personal thought when we started was that, yeah, this is not going to help. But we saw in several examples here that the attacker actually tried to register a second 2FA device, but failed. So they decided to circumvent the problem. In the Bybit case, and this is a little bit funny, so what they did is that they found out the working hours of the developer, and they knew that he was going to use the 2FA to activate the tunnel to the cloud. So they basically timed their working hours with his. So they hacked him in the morning and then, yeah, as they were working. But they were not able to circumvent the 2FA. Rust, really, really good programming language. It helps a lot when it comes to like getting the attack vectors to a reasonable level. That's as opposed to, say, JavaScript or TypeScript or other things that are like so popular out there and that are a defense nightmare. And of course, perhaps not shocking for you guys here, but something which I call Guardian protocols. So these are protocols that are very well battle tested and that are open source and that we have seen that they are effective for many years. Right. So what is hard information segregation? So from our perspective, we want to make sure that if you have an Office container and you then have a development container, even if you have like a full root exploit on the Office container, we want to make sure that the development container is still fully secure. And the goal here is to make sure that your integrity is preserved, right? It's to a lesser degree the availability or the confidentiality of the code. But it's the integrity that we are, of course, afraid of. Yeah, it works. Fantastic. I try to give people some kind of like visual understanding of what we're looking for. And I found that video pretty funny. Right, so we made a market comparison. So you can see this as a pain versus security graph. So if you're very far down that road, then you have high efficiency. If you're far down there, then you have low efficiency, and up there's a lot of pain, and down there is a little pain. Now, of course, for our client, the fact that Nokia was in the bottom left corner was of course very, very amusing and funny. And now, of course, obviously, blue and black wasn't the best choice of colors here. So excuse me, but you guys are perhaps not surprised that the US Department of Defense is on top, right? Now, this is where we try to be. Because our understanding of it is that if you're going to have like reasonable efficiency, we need to make the pain go away. But we also want to have high security. Right, because this is the problem. The flip side of the coin, why the 65% developers decided continuing developing on the laptop, although there was a like quote-unquote secure video solution available. People need to be able to work efficiently. You need to have reasonable performance. And yes, I'm sorry, most developers are prima donnas. If you have lag in the keyboard, they are going to go somewhere else. Why do people use VI? Must support reasonable functionality, shared clipboards, file transfers, and screen sharing. If it's not there, they won't be using it. The only thing that will happen if you decide to remove these functionalities is that the code is going to move somewhere else. Yeah, must support up-to-date and productive software. I mean, it sounds completely unreasonable, right? If you can't download and update your laptop to something which actually works, then you will be using your home laptop instead. Right, the Guardian protocols again, obviously TLS being one of them, not shocking for anybody in this organization. Also like to point out SSH here, because it is actually the hidden horse when it comes to development. So, this is sort of the goal that we set out for the project, right? So we want to be able to withstand 2 00 vulnerabilities. So that means that the attacker has access to 2, for us unknown, 0 clicks. That means there's no interaction with it. Vulnerabilities inside our Guardian protocols, and we should still be able to keep integrity of our software. We want also to be able to restore the integrity of our software even after full exploit. So that's why we're looking for blockchain technology to actually give us some form of like final respite. Because if you look at things like, say, SolarWinds, right? And you ask them, okay, so you had a full compromise of your build system. You have no idea how they got in. At least you're not publishing any idea about how they got in. How do you know that the code that you're now shipping doesn't contain any vulnerabilities? And they're like, yeah, we hope it doesn't, right? I usually say hope is not a strategy. So this is our target design. Bob here, a test user, he is running a forked version of the operating system called Cubes. I don't know if you guys have heard of it, but it's yeah, it's a reasonably secure setup. He then connects to the office environment, which is well, it's supposed to be blue, but yeah, let's imagine it's blue. And through there, he then goes further to a defensive layer, which is the development environment, and through there he can then use SSH to enter code into GitHub. The thing that you can sort of try to put in your head, it's basically a little bit of a medieval castle strategy, right? So the blue zone, this is the village outside the castle. We know when the ogres come around that that's going to fall, and we expect it fully to be burnt. So we don't keep anything there that we actually care about. It's mostly emails and documents and stuff like that. And then you have like the outer castle wall leading to the inner courtyard. So that's the development zone. This is where we try to keep the development safe. But even if that fails, obviously what we really don't want is the attacker inside the red zone, which is where we build stuff, and this is where we store the code. So that it can then be passed to the purple zone, where it's then being exposed to users, clients, whatever. Also note orange. This is quarantine. And this is to make sure that we have a process for handling things which perhaps are not directly work-related, but which you might need to do. So somebody sends you a link, you're not sure, open it in quarantine. Then you basically wall it off, put it into its own little container, and you have at least better protection than just your laptop. Ideally, if Safe would have been using this system, that Docker container would have been in its own orange box. And thereby the lion wouldn't have been able to eat the baby. This is a bit of a zoom in, so that you can see, and this is the development to Git setup. So as you see, we have taken three of the Guardian protocols and we stack them together so that it's a layered defense. With the hope that first we use GPG to sign it, then we use SSH, and then we run it through an IPsec tunnel. And the attacker needs to be able to penetrate all three for them to actually get inside the Git repo. We have offloaded the keys into a hierarchical key store that is off computer. So we have a phone, a special phone that we have sort of developed where we actually use the keys. Oh, sorry, where we actually deposit the keys, and then we use tools like SSH agent to actually do the signing on the laptop. So what happens is that you check in, you get a ping on the phone, you put your fingerprint there, and then it goes in. No passwords. And this is how we handle the keys. We have a master key that you keep somewhere safe, ideally in your safe at home or some book or something. And then from there we generate a device seed from for the key store, add a identity to that device seed so you can easily segregate your private life from your possibly consultant. If you're a consultant, that you might have one for the consultancy company and one for the customer. And then from there you get the different keys based on the protocols that you want, and you can then expose those keys into the environment. And yeah, these are the use cases that we feel are very important, right? That we want to be able to structurally transfer information from the office zone to the development zone. Things which we are a little bit hesitant about if it's like complex information. So somebody sending you a zip file, you're not supposed to take that directly into the office zone because you're supposed to understand what information you're transferring, right? So that one would go through quarantine. What we obviously do not want is what's in the red box. Somebody managing to run a script inside the office zone and from there be able to exploit your development zone. Right. Yeah. I have one Signal group and one Telegram group if anybody is interested to talk more about it. So this is our POC that we ran with the telco that I managed to get the result of, and I'm going to open source it, hopefully within a few weeks, to see if there are more people who are interested in this kind of setup. Questions?
Thank you very much, Rene, for your presentation. Yeah. I had just one question about the Guardian protocols. You mentioned IPsec. I was wondering, what about WireGuard protocol?
Yeah, so that's a very good question. Let me extend that question a little bit for you. So he asked, why am I using IPsec and not WireGuard? And I would also like to say, for instance, we had a good talk yesterday about another post-quantum-based VPN. So the reason why we have chosen IPsec is because it's OC standard. And it uses keys that are, for us, easier to integrate within the PKI that we have. And WireGuard is a really, really cool protocol. And it's easy to set up if you're a small company. It's a little bit more tricky if you're working in the enterprise segment and you want to do PKI, because it's really not, at least my understanding of it, it's not really catered to that. But yes, it's definitely an option, right, in the setup. The idea here and the important thing is that there should be like several layers that are there to protect you, making sure that even if a 0 days is found inside one of the layers, then you should be able to be safe. And of course, if you believe in post-quantum and feel that that is a threat level, then you could definitely use the VPN that I talked about yesterday instead. It's just a module, right? So you slot it in. I should also say there's an interesting sort of byproduct with IPsec. NSA hates it so much, so they decided to actually try to destroy it through over-engineering in the working group, right? So you can imagine that they are not very happy with the idea of having IP-based encryption. So that was another part. But no. I mean, you can definitely use WireGuard if you want, depending on your setup. Yeah.
Hi, you mentioned that you were surprised by the usefulness of multi-factor authentication.
Yes.
Sorry. In your experience, did you... sorry. Test. No.
Yeah.
No. Maybe now? Yeah.
Yeah.
Have you seen any differences in your experience between various methods of 2FA?
Possibly, right? So one of the reasons why my personal belief was that the 2FA is not going to help you is because we have seen in other use cases or threat cases that they have the ability to target your mobile phone pretty accurately with stuff like Pegasus. So my assumption was that if they are going for your gut, they're going to find out which 2FA you're using, and then you get Pegasus. And I would still assume that that would be the case if you're talking about a threat actor that actually is Pegasus capable. Now, in this case, both of the examples, both SolarWinds and Bybit, we didn't see any Pegasus deployment on the mobiles. That doesn't mean that other actors are not capable of doing that. And that, of course, includes the Israelis that are developing it, right? Also, what actually counts as a 2FA is a very broad spectrum, right? So in these cases, I think Microsoft Authenticator was the 2FA, which they decided to circumvent rather than to attack. If you're using SMS as a 2FA, I have a few YouTube clips that you really should be watching. Because that's basically putting a small plastic lock that you bought in the toy store on your safe. More questions? No? Yeah, I guess we are done then. Thank you.